Okay, we're back. We're gonna go through the rest of the practice problems in the test nav practice SOL for chemistry. And again, I want you to note that you do have, as I'm going through it on the screen, I can't really write anything down as I go. So remember, you do have access to this handout that shows the work that I'm discussing, all right, and the different concepts. So like when we get to question 16 is a pretty tough question. We got a stoichiometry set up and all that stuff. So you might want to reference this as you're watching the video. You might want to see where I'm getting all the information from. All right. So again, this is in the same folder. Just open it up and check it out. All right. So let's get back to it. All right, so we left off on question 16. All right, it says excess oxygen reacts with 24 grams of iron to produce 332 grams of iron 3 oxide. What is the percent yield? All right, so I would say 98% of the students that take the SOL, if you get a question like this, 98% of students are going to fall for the trap answer, which is C, because they're not really going to think about what was given to them. They're just going to take small number and divide it by big number and multiply it by 100. And guess what? When you do that in your calculator, you get 73.5%. And so a lot of people are just going to get, hey, I did something in my calculator, and this is the answer that showed up, so that's got to be it. Okay, that is not the answer. All right, that's the trap one. Okay, so percent yield is actual yield, what was actually produced in your lab, divided by what you theoretically should have produced times 100. So this is not actual yield. This is how much iron I'm starting with, okay? This is the actual yield. So what you have to do is you have to figure out the theoretical yield, and then you'll take 332 divided by the theoretical yield times 100 to get the percent yield. And the way you're going to have to do that is, one way to do it is treat the whole thing like a stoichiometry problem. And so you have to write your balanced equation. So I have the work shown up here. So the work that's going on is 4 irons plus 3 oxygen yields 2 Fe2O3. So that's the reaction, okay? And then what you have to do is figure out, well, if all 244 grams of iron react, how much Fe2O3 should I get? So I take my grams of iron divided by the molar mass of iron. I got that from my periodic table. And I'm just rounding here because the numbers aren't that close to each other. So I can afford, instead of saying 55.85, I can say 56. The mole ratio is 2 to 4, 2 moles of the rust for every 4 moles of the iron. And then multiply by the molar mass of Fe2O3, which is 159.7, but I'm just rounding to 160. And so theoretically, I should have gotten this much. So what you're going to do is take the 332 that you actually got, divided by what you theoretically should have gotten times 100, and it comes out to be 95. So the correct answer is B. All right. So, whoops. Flip back to my pointer tool, and there we go. All right. All right, so the next one, here we got another stoichiometry setup. So we're starting with 147 grams of water produced. How much ammonia reacted? So let me go back to my PDF here. All right, so we would take our grams of water, convert it to moles. So we would divide by the molar mass of water. We can calculate it using our periodic table. 2 hydrogens, 1 oxygen. The mole ratio is 2 to 1. 2 moles of ammonia for every 1 mole of water. And then we wanted the mass of ammonia. So right now that gives us moles of ammonia. So we got to multiply by the molar mass of ammonia. And again, we'd have to break out our periodic table and say 1 nitrogen and 3 oxygens, or sorry, 3 hydrogens have this mass. So we would divide by 18.02, multiply by 2, multiply by 17, and we get around 278. Okay. All right. All right, so which is the best estimate for pH of a solution when you get into hydroxide? So this is where we got to be careful, because I know you've probably covered the equations on how to calculate pH and pOH, and that pH and pOH always equals 14. Understand hydroxide is the OH minus concentration. So if you have the hydroxide concentration and you take the negative log of that, you take the negative logarithm of that. That gives you the pOH. You have to remember then to subtract from 14 to get the pH. Okay? You see, do they have the log function here? No. Okay. So this is when it would, benefit you to have a graphing calculator with a log button, because all we have to do is hit negative log of this, and that'll give us the pOH, and then 14 minus that answer will give us the pH. And so that's our answer. But let's talk about how we can estimate it, okay? If you don't know how logarithms work, don't worry about it. If you have something written in scientific notation and you take the negative log base 10 of it, the answer is going to be very close to whatever that exponent is, but as a positive value, all right? So the closer this number is right here to 1, the closer the exponent is going to be to your answer. So the negative log of this is about 5. So that means the pOH is around 5, okay? So if you do 14 minus 5, that means the pH is around 9. And so, boom, 9, all right? There you go. All right. So we got to know our gas law relationships, all right? This is a P and V relationship. So the volume changes, what's going to happen to the, here's the volume, and if the pressure's doubled, what's going to happen to the volume? So the volume starts out at 50, and if we double the pressure, what's going to happen to the volume? And you got to know that pressure and volume have an inverse relationship. So as one goes up, the other goes down. So if the pressure increases by a factor of 2, which is doubling, we know the volume has to decrease. So we know it can't be that, and we know it can't be that, because pressure and volume don't have a direct relationship. And then so again, if the pressure doubled, that means the volume is just going to cut in half. So decrease by a factor of 2. Okay. All right, so this one's kind of weird. We have to plot 2 points. So notice, like, if I plot a point here and a point here, it connects them. All right. But let's talk about what we got to do. It says we got to graph the data set that correctly shows the relationship between volume and moles of gas at STP. So what you have to know is that at STP, 1 mole of gas will occupy 22.4 liters, okay? And you should understand that the more moles of gas that you have, the greater the volume, so they have a direct relationship. So I know that this data set B, is wrong, because as the volume increased, the moles decreased, and they should have a direct relationship. So as moles increase, volume should increase. So this doesn't have the right relationship. So data set A has a correct relationship in terms that it's direct. As volume increased, so did moles. And same with data set C, as volume increased, so did moles. But which one is correct? Is it set A or set C? Well, this is when we have to understand that at STP, 1 mole of gas is 22.4 liters. So here, I got 1 mole of gas, 1.1, and the volume is nowhere near 22.4. It's only 12 liters. So that's not right. But here I have half a mole of gas, and the volume's close to half 22.4. So this is the better data set. So we got to graph it. So we got to find moles. So I got to find 0.5 and 12. So I put that line, and then I got to go to 0.7 and 15. And then it connects automatically for me, and that's my graph. All right. So for 21, we are given the heat of vaporization, which is over here, and the heat of fusion. But notice the question is talking about melting point. So as soon as I see that, we're talking about melting, I know I'm not going to use heat of vaporization. I'm only going to use the heat of fusion. Not going to use heat of vaporization, just the heat of fusion. Okay? So heat of vaporization is for vaporizing and maybe condensing. Heat of fusion is for melting or freezing. Okay? So this is going to be some nice dimensional analysis. We got to take our total amount of energy and divide it by this, and that'll convert it to moles. And then once we have moles of this, multiply by the molar mass of that to get grams. So let me go to my PDF. I'll show you how the setup would work. So this is the total amount of energy. The way to interpret this is this much energy for every 1 mole, or you could flip it and say 1 mole of that substance for every 4.6 kilojoules. That'll cancel out kilojoules. So if I take 7.8 and divide it by 4.60, that'll cancel out kilojoules. And then this is the molar mass of CH2Cl2. So 2 chlorines, 2 hydrogens, and 1 carbon adds up to around 85 grams. So I would divide by the molar heat of fusion and multiply it by the molar mass, and it comes out to be 144. But the trick is you don't have to use this. This is if it asks for how much you could boil at the boiling point, then we would do 7.8 kilojoules. We would divide by that number instead of 4.6, and then multiply by the molar mass. But because it's talking about melting, I got to know I'm going to use the heat of fusion. Okay, so again, it comes out to be around 144. All right, so we'll keep going. All right, so organic means it has to have at least 1 carbon and 1 hydrogen. So yes, yes, and yes. The rest don't. Okay. Saturated means all the carbon bonds are single bonds, so it would have to be that one. All right. The best geometric shape here, so it would be carbon with 4 single bonds to hydrogen. So this could be an answer, but remember, they want to spread out as far as they can. So this is the better answer. And remember, when you see these wedges, it means, this means coming out of the paper. It's trying to show you 3 dimensions instead of 2 dimensions. So this is coming out at you, and that's going back away from you. And it shows you that the bond angle is actually greater than 90, okay? But that wouldn't be good because the bonds would want to spread out as far away from each other as they could, all right? All right, so here it's saying select 3 carbons that make the molecule unsaturated. So that means carbons that have either a single bond a double bond or a triple bond. So not this carbon, because it's all single bonds, but this carbon has a double bond, so I could select that one. This one has that same double bond, so I could select that one. This carbon has a triple bond, so I could select that one. But I could also select this carbon, but it's only allowing me to choose 3 because notice that warning comes up, and it's only allowing me to use 3 because it says only select 3. But those 3 would work, or you could do this one, or you could do that one or that one. The ones that you could not select are this one, because it's all single bonds, and this one, because it's all single bonds. All right? All right? Naturally occurring. So I tell my students, naturally occurring means something that you heard about in biology. So I didn't hear about nylon in biology, but I did hear about proteins and DNA. Okay? If you heard about it on an infomercial or commercial or something, then it's probably synthetic. If you heard about it in biology class, natural. Okay. And then the last one. Okay, here, this kind of goes, again, with what I just said, plastics versus nucleic acids. Nucleic acids like DNA, deoxyribonucleic acid, natural. Plastics, synthetic. So choice A, plastics are synthetics, and nucleic acids are natural polymers. All right. So that's it. That's all 27 practice items. If you took that and you understood and you know what to do, again, it's good to practice. So you have some practice tests available to you in the Schoology group. The answer keys are there. It's good to review. It's good to test prep. Just remember, when you take the test, you need to review, but on test day, and right before test day, like the morning of or the night before, I think it's really important that you make your own cheat sheet. Make your own cheat sheet. Actually write it down, memorize it, have it with you as you're walking into the test location, wherever it's going to be. Throw it in the trash or recycling. Go sit down and just be patient. Listen to the proctor's instructions, listen to the examiner's instructions, and as soon as you get that scrap sheet of paper, start recreating the formula sheet from your memory, okay? And then when they say begin the test, if you haven't done it yet, if you haven't completed your formula sheet, don't begin the test. Finish up your formula sheet, take 10 minutes, take 15 minutes, and then start your test. So you have that there as a reference. You probably won't ever use it, because you sat there and wrote it down. It's already in your head, but it's just another reminder. And if you need to use it, it's there. Okay, so I can't stress how important that is, especially those of you that are kind of, borderline and you think you might end up failing this thing. It could be the difference between, 2 or 3 questions if you do it versus you don't. And that could be the difference between, failing and passing. And it could also, for those of you that, are really good at chemistry, it could be the difference between a regular pass and a pass advance. So if you're looking for a pass advance, do the same thing, all right? So you don't make silly mistakes. All right. So hopefully this is beneficial to you, and good luck on the SOL.